All right, finding horizontal asymptotes whenever doing rational functions. This one is somewhat of a doozy. Please make sure you take really good notes. Put a box around all of our rules, and that way you have something to refer to. Horizontal asymptote actually has 3 different scenarios, and all of them will deal with the degree. All right, so quick reference of what degree is. Degree is the highest exponent. All right, so we're going to be looking at the degree of the top of the function and the degree of the bottom. All right, so that's what I'm talking about when I'm referencing degree. Well, if the degree of the top is the same as the degree of the bottom, so degree of the top equals degree of bottom, then you're going to find your horizontal asymptote at y equals the leading coefficient of the top divided by the leading coefficient of the bottom. And this is what I'm talking about. Let's say we have 3x plus 2 over x minus, or x plus 1. All right, so nothing cancels. We factor it, nothing cancels. Look at your degree. Your exponent up here is a 1. There's nothing there, so it's understood to be a 1. Down here, the exponent's 1. Again, there's nothing there, so we understand it to be a 1. That means the degree of the top and the bottom are the same. So now we take it and go y equals, we divide the leading coefficients. Well, the leading coefficient of the top is going to be a 3. The leading coefficient of the bottom, there's nothing in front of the x, so that's a 1. So that makes my horizontal asymptote for this problem at y equals 3. One more example, x squared over x squared minus 4x plus 3. Degree of the top is 2. The degree of the bottom is 2. All right, so look at your leading coefficients. Y equals, the top is 1, the bottom is 1, so 1 divided by 1 equals 1. So my horizontal asymptote for this problem would be 1. So that's the first scenario, and one of the easier scenarios. The degree of the top equals the degree of the bottom, so simply divide their leading coefficients. Rule number 2. The degree of the top is less than the degree of the bottom. Then this one's super easy. Y equals 0 is going to be your horizontal asymptote. All right, y equals 0. Well, this might be like x plus 1 over x squared minus 9. Okay, the degree of the top is 1. The degree of the bottom is 2. Therefore, the degree of the top is less than the degree of the bottom, so y equals 0 for your horizontal asymptote. Degree of top, degree of bottom. So this one's 1, that one's 2. Another scenario might be something like this. Degree of the top. There is not a variable. Okay? Since there's not a variable, that means our degree is 0. Degree of the bottom, it's just x, so it's just a 1. So your horizontal asymptote again would be y equals 0. So if the degree of the top is less than the degree of the bottom, then y equals 0 is always going to be your horizontal asymptote. One last rule. Rule 3, if degree of top is bigger than degree of the bottom, then there's not a horizontal asymptote. And that actually turns into where there's going to be a slant asymptote. Okay, and we'll talk about that on our next video. But there's no horizontal asymptote, there's a slant asymptote. This might be in a case like x squared plus 9 over x minus 4. The degree of the top, highest exponent, is a 2. The degree of the bottom is a 1. Top is bigger than bottom, so no HA, no horizontal asymptote. There's going to be a slant, and we'll discuss that in our next video. Okay, so 3 rules for horizontal asymptotes. Degree of top equals degree of bottom, divide your leading coefficients. Degree of top less than degree of bottom, the y equals 0. Degree of top greater than the degree of the bottom, then that means there's no horizontal, there's going to be a slant.